Alrighty. So who can tell me what is the goal for substitution? Like what are you looking for when you solve using substitution? When we solve, our solution is going to be an ordered pair, but what is the purpose of using substitution? Why would we choose to use substitution? What do we do? What is the process? You guys remember? So we want one variable to be isolated. Here's an example. If we have an equation that says y equals something, y is isolated, right? We have y all by itself on one side. You use the expression that equals y to substitute in to the other equation. So if our second equation was 2x minus 4y equals 12, we would take this expression. We know that y is equal to the expression 2x plus 3, and we would take that and we would substitute it in right here for the variable y. So what would that give us? Well, that would give us an equation with no y variable. We're essentially eliminating the y. So we would actually have the equation 2x minus 4 times what is y? Y is the expression 2x plus 3 equals 12. Okay, and then you would solve that. So the whole goal behind using substitution is that you can isolate one of the variables. Now, sometimes your equations in your system are really nice. You have 2y equals, or sometimes you have a y equals and then an example like this, something in standard form. So you already have one of the variables isolated. But that's not always the case. That is not always the case, okay? Sometimes you actually have to manipulate the equations. Raise your hand if you need more time with that. Gotcha. So we're going to use this idea of looking for a variable that's isolated and substituting that in to the second equation. So the system that we're working with is represented by the equation 4x minus 2y equals 14 and x plus 2y equals negative 4. Tyler, are you good with the words or are you still writing those down? Okay. So the first thing that we want to do is look for a variable that we can isolate. Because I don't have a y equals or an x equals equation, do I? So I have to look for a variable that I can isolate. And typically that happens when the coefficient is 1. It's easiest to do when the coefficient is 1. So when you look at the two equations, let's see, 4x minus 2y equals 14. So my coefficients, my numbers that are attached to my variables in that equation are 4 and negative 2. So I don't want to do anything with that top equation. When I look at my second equation, x plus 2y equals negative 4, my coefficients are 1 and 2. The x really has a coefficient of 1. So that's going to be the easiest equation to manipulate. That is going to be the easiest equation to manipulate. So we are going to solve for x using equation number 2. So how am I going to make this look like x equals? What am I going to do? How am I going to make that x plus 2y equals negative 4? Just say x equals. What should I do? Any ideas? How can I get x all by itself? I want x to be the only thing on the equals, that's left side of the equal sign.
Subtract 2y.
Yeah, we're going to subtract 2y from both sides. I purposely chose this because it's not typical that we solve for x. You guys have an okay time solving for y because we've been putting equations into slope-intercept form for quite some time. But to solve for x, that's just not something that you automatically think of. It's not comfortable, right? So x equals, this cancels out, negative 4 minus 2y. So I have x isolated. The x variable is all by itself on the left-hand side of the equation. So it is isolated. So now what are we going to do? Well, we are going to use the expression that is equal to x and substitute into equation number 1. We're going to substitute it into equation number 1. So what does that mean? That means that I'm taking this expression, negative 4 minus 2y, because this expression equals x, and I'm going to plop that in the place of x in the first equation. That's what that means I'm going to do, okay? So that's what we need to show. We need to show that. Let me move this guy out of the way. Okay, so we're going to write the equation. I'm using this first equation right here. So 4 times x, but what did we say x is actually equal to? Negative 4 minus 2y. Now I have to finish this equation. Minus 2y equals 14. Minus 2y equals 14. So again, I took this top equation, 4x minus 2y equals 14, and I just replaced the x with this expression. I still have to finish out the rest of the equation. So now what am I going to do? How do I get rid of this parenthesis? What operation is this? I have to distribute. 4 times negative 4 is negative 16. 4 times negative 2 is negative 8y minus 2y equals 14. So it looks like I've only got the variable y to solve for. How are we going to do that? Combine like terms. I agree. So that negative 8 and that negative 2y both become a negative 10y. Good job. Negative 10y minus 16 equals 14. What do you want to do next? Owen?
16.
Sure, we're going to add the 16 to both sides. So negative 10y equals 30. Now what?
Divide both sides by -10.
Divide both sides by negative 10. So I know that y equals negative 3. Am I all done with this? What do I have to do next?
Find out the second half.
Yeah, remember that your solution is an x comma y ordered pair. God bless you. So you're going to have to make sure that you find both. You have to find both. So again, this is our next example. I'm going to move this out of the way. So what equation do we have to use? Does it matter which equation we use to find the value of x? It doesn't. It doesn't matter which equation you use. It just has to be one of the originals. So do you want to use equation number 1, 4x minus 2y equals 14, or equation number 2, x plus 2y equals negative 4? Number 2. Okay, so we're going to take the equation x plus 2y equals negative 4, and I am going to take the value of y, and I'm going to plop it right there. That'll allow me to solve for x. So let's see. X plus 2 times negative 3 equals negative 4. So now what do I need to do? And what is 2 times negative 3, Tim? So x minus 6 equals negative 4. Last step. Add 6 to both sides. Good morning. Excellent. Thanks. Add 6 to both sides, and I find out that x equals what? X equals 2. How do I write my solution? Good job. In parentheses, 2 comma negative 3. How do we feel about that? Okay. Can we practice one more? Raise your hand if you're still writing or if you need more time. Everybody's good? Okay, so here's our next system. This is our next system. 2x plus 3y equals 15, and 3x plus y equals 19. So which variable is going to be the easiest to get isolated? Which variable is going to be the easiest to get by itself? Which one has a coefficient of 1? What do you think, Owen?
The second one.
The second equation, what variable are you going to get by itself?
The 3x.
The y. Yeah, when you look at this, you want to look at the second equation for sure, but y has a coefficient of 1. So in this example, we're going to solve for y. We're going to take our second equation and we're going to get y all by itself. So let's do that. So I'm just going to draw an arrow that says first solve for y. So what does that look like? If I have 3x plus y equals 19, how do I get that all by itself? 3x plus y equals 19. Subtract the 3x from both sides. Yeah. So when I subtract 3x from both sides, I have y equals 19 minus 3x. Y equals 19 minus 3x. So we've manipulated that bottom equation, that second equation. So what are we going to do next? Say again. No division, nothing. I'm going to look at this top equation. So second, we are going to substitute the expression that equals y into top equation. I'm going to substitute that expression that equals y into the top equation. So I'm going to write the top equation, 2x plus 3y equals 15. And I'm going to circle my expression. My expression is y equals what? Y equals the expression 19 minus 3x. So I'm going to take that 19 minus 3x and I'm going to plop it right there where the y is. Okay? So let's see, what's that going to give me? Parenthesis. Perfect. Very nice. All right, so it looks like I have to do some what to get rid of my parenthesis? Yeah, I have to distribute. So nothing happens to my 2x. 2x plus, well, 3 times 19. Let's see, what's 3 times 20? 60 minus 3, because the 19, 57. Good job. And 3 times negative 3x is a negative equals 15. Okay, so what are you thinking we should do next? Combine like terms. Yeah, I need to take this 2x and this negative 9x and combine them. What does that give me? Negative 7x plus 57 equals 15. Now what? Subtract 57 from both sides. Negative 7x equals negative 42. What do you want to do next? Divide. Yeah, divide both sides by negative 7. And I find out that x equals a positive 6. X equals a positive 6. Are we done? What do I have to do next? Third, use x equals 6 and substitute into one of the original equations. Does it matter which one we substitute it into? It does not. It's just got to be one of the original ones, not the ones that you've manipulated. We do that in case you make a mistake when you're manipulating. So do you want to use the top equation, equation number 1, or the bottom one, equation number 2? Equation 2. So we're going to use the equation 3x plus y equals 19. But we know that x equals what? X equals 6. So I'm really going to write this as 3 times 6 plus y equals 19. What is 3 times 6? 18 plus y equals 19. So when I subtract 18 from both sides, I find out that y equals 1. Am I all finished? Write it as an ordered pair. Good job. So what does my ordered pair look like? 6, comma 1. You have to write your ordered pair X, Y, ordered pair. X, Y, ordered pair. Okay. All right. So we have